Burettes are commonly used in titrations and are designed to accurately and easily measure the volume of a dispensed liquid. The 50 milliliter burette, as shown here, is the most common size and has graduations of 0.1 milliliters. However, with a little practice, it is easy to measure volumes to an accuracy of plus or minus 0.02 milliliters. You must ensure that the burette is clean. If it is dirty, droplets of the titrant can stick to the walls of the burette, affecting the measured volume. Do not use distilled water to clean the burette. Instead, you should use a small portion of the titrant that you will be using for the experiment. Place some of the titrant into a small beaker, and then carefully transfer a small volume, about 10 milliliters, into the burette. Gently roll the burette to wash the inner walls with the titrant, being careful not to let any spill back out the top. Clean the tip of the burette by opening the stopcock and allowing some of the titrant to flow through. Then close the stopcock, tip the burette over, open it once more, and allow the remaining titrant to flow through the top of the burette. Collect all of these titrant washings in a waste container and dispose of them in an appropriate manner. If necessary, repeat this cleaning operation. The burette clamp has indentations in which the burette rests, but it can be difficult to see if the burette is properly clamped when viewed from the front. When securing the burette, view the clamp from the side, and straighten the burette if necessary. Use a small beaker containing the titrant to fill the burette to a mark near the top of the graduations. Do not attempt to align the titrant level with the 0 milliliter mark on the burette. It is not possible to align the titrant level with the 0 milliliter mark to an accuracy of plus or minus 0.02 milliliters. As long as the titrant level falls within the graduations of the burette, an initial reading can be obtained, and the volume of dispensed titrant can be determined by difference. The air in the tip of the burette must be flushed, so open the stopcock and allow some of the titrant to flow into a waste container. Watch that bubbles do not remain in the tip. If they do, flush again until they are completely removed. It can be difficult to see the meniscus of the titrant unless something is placed behind the burette to provide contrast. Simply placing a piece of white paper behind the burette will make it easier to read the level of this meniscus. It is essential to view the burette from the same level as the titrant when taking a reading. Viewing the meniscus from above or below changes its apparent position. This is known as a parallax error. In this example, we are viewing the titrant's meniscus from above, and the bottom of the meniscus appears to be near the 2.2 milliliter mark. Also note that each milliliter mark on the burette goes completely around it. When viewed from this angle, these marks appear to be elliptical, but when viewed from the same level, they appear as a single line, as the mark on the front and the rear of the burette come into alignment. Watch how these milliliter marks change as we move to a view level with the meniscus. Now that we are viewing the meniscus from the same level, the nearby 2 milliliter mark appears to be a single line. However, note that the 3 milliliter mark still appears to be elliptical because we are viewing it from above. Recall that when we viewed this meniscus from above, it appeared to be near the 2.2 milliliter mark. Now, when viewed from the same level, it appears to be closer to the 2.3 milliliter mark. And as you will see, as we move to a view from below the meniscus, it will appear to move further down the burette. The meniscus now appears to be close to the 2.4 milliliter mark. This illustrates that if care is not taken with the angle at which the meniscus is viewed, it can appear to vary by as much as 0.2 milliliters. If accurate burette readings are to be obtained, your eye must be at the same level as the meniscus. Generally, the level of the titrant is measured from the bottom of the meniscus. An exception to this rule will be presented later. In this example, the initial burette volume lies between 2.2 and 2.3 milliliters. We can use the thickness of the lines on the burette to give us a more accurate measurement of this initial volume. The thickness of a line on a 50 ml burette is roughly equivalent to a volume of 0.02 milliliters. That is, one of these lines takes up about 1/5 of the distance between two consecutive 0.1 milliliter marks. In this example, the bottom of the meniscus lies approximately one line width above the 2.3 milliliter line, and therefore would be assigned as 2.28 milliliters. If an intensely colored titrant such as potassium permanganate is used, it may not be possible to distinguish the bottom of the meniscus. In such a case, the top of the meniscus should be used as a reference point. In this example, the volume would be read as 3.08 milliliters. If an indicator is being used that changes color at the endpoint, it may be beneficial to place a sheet of paper under the titration flask. In this experiment, phenolphthalein has been added to a strong acid in which it is colorless. As the strong base titrant is added, the phenolphthalein will turn pink. If you are right-handed, hold the titration flask in your right hand and the stopcock in your left. You will control the flow of the titrant with your left hand while swirling the titration flask in the right. If you are left-handed, reverse this process. As the titrant is added, the color associated with the endpoint will be observed where there is a local excess of the titrant. Swirling the flask will mix the reagents and this color will disappear. However, as the endpoint is approached, this color will become more persistent. The rate at which the titrant is delivered should be adjusted as the titration proceeds. At the beginning, add the titrant in a steady stream with constant swirling of the titration flask. As the endpoint is approached, add the titrant dropwise. If it appears that you are very close to the endpoint, you may wish to wash the last drop of titrant from the tip of the burette with some distilled water. If you suspect that you are extremely close to the endpoint, you may wish to form a single drop of the titrant at the tip of the burette and then wash it off with a small amount of distilled water. You should prove to yourself that adding a small quantity of distilled water will not affect the position of your endpoint. This titration mixture was suspected of being close to the endpoint, so only one drop of titrant was added. Notice that the phenolphthalein turns pink due to an excess of base from the titrant, but it slowly turns colorless as carbon dioxide is absorbed from the air, forming carbonic acid, which consumes the slight excess of base. To confirm that this mixture is actually at the endpoint, the drop of titrant on the burette tip was washed off with distilled water. The pink color returns and persists. This confirms that the endpoint has been reached. The color change of the indicator is very sensitive. This will be illustrated by adding one more drop of titrant. The image on the left shows the titration mixture at the endpoint. Adding one more drop of the titrant yields the image on the right. The more intense color of the indicator in the latter image indicates that the endpoint has been overshot. When seeking the endpoint in a titration using an indicator, look for the first faint but persistent color change. Do not seek an intense color change. To complete the titration, we need a final burette reading. In this example, this volume would be read as 26.34 milliliters. Now, to establish the volume of titrant that has been dispensed, we take this final burette volume and subtract the initial burette volume. In this particular titration, 24.06 milliliters of titrant was dispensed. Always record the volume of titrant to 2 decimal places.